So welcome back. We're going to continue our session. And the second talk in this block is leveraging user behavior data to create effective filter suggestions from Juan Lapadula and Joel Widmer from Digitec Galaxus. So welcome.
Okay. Now it works. Okay. So welcome to our talk. My name is Joel. This is Juan. We are both software engineers at Digitec Galaxus. And today we will tell you how we leverage user behavioral data to create effective filter suggestions. First, let me tell you some things about our company. So we are Digitec Galaxus. We are the largest e-commerce retailer and marketplace in Switzerland. And we're also present in 6 other countries in Europe. So that totals to a number of 7 countries. And now, because we are present in all of these countries, our shop is available in 5 languages. Some of them we translate manually, and some we translate using AI models. We have around 200 million searches each year, which with a peak at over 1 million searches on Black Friday. Then revenue-wise, last year we had a revenue of 2.4 billion Swiss francs, which is around 2.4 billion euros. Now, here are some very serious pictures of our search teams. I'm saying search teams because we recently split our search team into 2. We now have 2 teams. One is more focusing on features and the front end, and one is more focusing on the relevance topics. That's why also we have 2 speakers. Juan is representing the feature team, and I am representing the relevance team. So far for our introduction. Now let's look at what we actually want to talk about, and that's filter suggestions. So let me just give you some small motivation on the problem. So let's say I want to buy a new umbrella, and I am going to our site and I'm searching for umbrella, and I'm presented with like 3,700 products, right? So naturally I would want to filter down these products, and now I'm presented with something like this. And even though we are very proud of having such detailed product data at our company, we understand that this might be a bit overwhelming for a user. So what I would want as a user was some smart suggestions that might help me in my search journey. So maybe something like this. Maybe I want some suggestion for price, for kinds of umbrella, or maybe given that I'm a man, maybe I would want umbrellas for men, right? So this is actually what we achieved. Here you can see a screenshot from our website. Right above the regular filters, we have up to 5 filter suggestions, and we call them quick filters because they allow you to navigate quickly through the filters. And in the remainder of this talk, we will tell you how we built our system and how we, just our journey, how we progressed at reaching this point. And I can tell you it's a very popular feature. So yeah, be excited to hear what we have done. And for this, I give the word to Juan.
Thank you. So, yes. So, of course, he just showed the end state where we are today with the quick filters, but this didn't happen from moment to the next one. And at the beginning, the only thing that we had was a hypothesis, right? We thought our filters are too complex sometimes, and we want to help the user to find the products faster, quicker. But this was just an hypothesis, of course. I mean, we were not sure, it's just a hunch. And we cannot make an infinite effort because we don't have infinite money and infinite time to implement the perfect solution. So what we did was, or what we say was, okay, we are going to do an MVP for this new feature and see what happens. So our approach was, I mean, it's an MVP, right? We said we want to spend very, very little time, make it as simple as possible. And what we did was, okay, we said we are going to show the most popular options of the most popular filters. So maybe you see my mouse? Yes, perfect. So we said, okay, we find out which is the filter that is clicked the most. And from this filter, we see which options are clicked the most. So you see here, for example, these are the options. And from processor family, all the quick filters belong to this filter. So it's like Core i7, 12th generation, 10th generation, blah, blah, blah. So very rough, let's say. But we thought, okay, this is enough for us to validate our hypothesis. Here we also did some assumptions. So not all types of filters are considered. And very important, the implementation was very quick and dirty. So we just calculated once the set of quick filters for each specific query, right? And then we had, okay, PC, German, the quick filters are those that you see on the top. And as you can see, the UI is very, very simple. We didn't refine much. We kind of reused what we had. Before I continue, I want to demystify something in this slide. And here you see the word model. And I'm an engineer. I don't work in data. So if I see model here, I have no clue what is going on behind, right? This can be, for me, it's a black box with unknown complexity. But this here is a big query. Okay, so it's something that everyone can do. It's not something crazy. Our tracking data is in BigQuery, and when we say model here, it means it's a query. So just the non-data people know that this is not, it's a ML and AI and stuff like that. I mean, this is kind of an anti-buzzword, right? What I just did, but it's like this, So we built the MVP, this very rough version of the feature, and we launched an A/B test. So 50% of the users might see quick filters, this new feature. 50% of them will for sure not see them. And we saw the following. First, we saw a drop in the standards filter usage, compensated by usage in the quick filters. That means the users clicked the quick filters instead of clicking the normal filters, right? The maybe 21 options that you might see. So this is good. This is, kind of validating the hypothesis. It adds some value, maybe, if we do it right. But the second part, which was not so amazing, was we saw no clear winner in the click-through rate of products. So the users were clicking the quick filters, but it was not 100% sure for us, okay, they are finding better their products. So this is kind of a little bit mixed, right? They use the feature, but it's very simple, let's say, and then they are not clicking that much the products, or it's not a huge improvement. Nevertheless, we knew, right? This model is extremely simple. We spend little money, little time on this, and we can expect that the CTR did not improve. So we took this as a win. Okay, hypothesis is validated. The users would get or might get some value from this feature if we suggest the right options. And that gave us to the second iteration, where what we did was a more complex model, a different BigQuery query, of course, where we were picking not the most popular filters, not the most popular options from any of these gray pills, but from the whole query. What is the people clicking the most? And then this is our set of quick filters, and then you have examples here, like it should be below 600 Swiss francs or euros or whatever. It should be, if you search for PC, a lot of people is searching for a desktop PCs or a gaming PC or with 32 gigabytes of RAM. So this is like the next iteration, a little bit more sophisticated, also not so quick and dirty. Now, the options are not hard-coded for us. They are recalculated daily, so we can react also to the different changes in the user behavior. And we improved the UI. So for the only person here of UX, I know there is someone from UX. Yeah, for you. This for the technical people, this might mean nothing, that you are using most popular options from any filters. But in UX, that is a challenge because you have a lot of information that we need to show in a very small place. So this is like in the technical mind, this is nothing. But in the UX mind, for the users, it's a little difficult, or yeah, you need to make some assumptions to create this UI, because you cannot put like huge all the labels and all that stuff there. Then the quick filters are huge, or in mobile you don't see anything. So also that. So we had to invest more time in every part, right? In the model, in the engineering, and in the UX. Then for this second version, we also launched an A/B test where we're comparing no quick filters again, with this new model, we didn't compare old model and new model. We just improved this one and launched again the A/B test. And what we saw in the usage is that it didn't change much, which is a little bit underwhelming, because they were clicking almost the same, the quick filters, as the normal filter, as in the previous version. So I don't know, maybe there is some kind of position bias there that I see options on the top of my page, I need to click them. I don't know. Not a huge change there, but what was very rewarding is that we saw a significant increase in the click-through rate on the products. So now we are sure, after running this A/B test, if we show quick filters for a given query to the users, it's more likely that they are going to click a product, find what they are looking for, and be happy, basically. And with that, I will give back to you.
Thank you, Juan. So now that we are happy with our current implementation of the MVP, it's now time to expand our model, aka BigQuery query, with some new signals. And because we are using just tracking data, we somehow have to squeeze out more information from basically the same data. And what we observed is that maybe a click that happened yesterday has a different meaning than a click that happened 1 year ago. So I put the slogan, not all clicks are alike. So the idea is basically, instead of just summing up all the clicks over basically all time, right? We weigh the clicks based on their recency, and then sum up the weights of the clicks. So I have an example here. Let's say we want to measure how popular is a filter, or was the filter over the last year. And because it's relevant right now, we weigh clicks that happened recently a bit more than clicks which happened 1 year ago. So I have here a very small example. Let's say filter option A has 5 clicks from yesterday and 10 clicks from last year. Filter option B has 12 clicks from yesterday. Now, which filter is more popular, right? So our old model would say filter option A is more popular because it had more clicks. Now, in our new model, we would maybe say the popularity score of A would be 5 times 1 for the clicks from yesterday plus 10 times 0.5. So we weigh the clicks from last year a bit less, so it gets a score of 10. And then the popularity score of B is still 12. So according to our new model, the score of B is a bit higher. Now you can extend this idea to other signals, right? Maybe we want to capture very new trends, or maybe we want to capture seasonality. And so I just show you the weight distributions of what that would look like. So for trends, we want the distribution that gives a very high weight to very recent clicks, and then a very decreasing weight distribution. So maybe a click 2 weeks ago already counts for nothing. On the other hand, if you have seasonality, right, the score for seasonality might be clicks that happened recently and also clicks that happened 1 year ago, because clicks from 1 year ago might tell you something about clicks right now, or like the popularity right now. So if people are buying, let's say, sandals in summer, right, they also bought sandals last year. And now we have these different weight distributions and these different scores. And what you can now do is just sum them all up into one final score. And this is now what decides which filters we show. Now, one other benefit of having such a simple model, right, is that we can actually understand what's going on. So let's use our umbrella example again. Let's say as a developer, I want to know, why are these filters here? So let's say I want to know why Pocket Umbrella is here, and now I can look at the scores. And then I see, okay, Pocket Umbrella has a high popularity score, a somewhat middling trend score, and a very low seasonality score. What that tells me is that throughout the year, this filter is used a lot. But it's not like it's pretty constant throughout the year. if you compare this to parasol, which is like a sun umbrella, right? Then you have, it's very, has low popularity, so it's not clicked throughout the year, but it has high seasonality. So last year in summer, people were also searching for parasol. This is just, for us as developers, this is a useful tool, right? It helps us understand how the weights in our model works and just how we can adapt to maybe make it a bit better. Now, let me just summarize again our learnings from this experiment or this task. So we can elevate click data by assigning weight to the clicks. Very simple, and a simple model is explainable, and it helps us develop it further. And now I would like to tell you some nice improvements in our KPIs, but unfortunately I have to tell you some pitfalls we had. So because we had success with basically the same model in a different context, we decided to not do an A/B test. So that was our first mistake. Then again, for the UX person, we did some minor UX, not minor, some UX changes to the quick filters themselves at the same time. Basically, that meant changing the color, changing the positions of the filters. And we did that at the same time. And also, we deployed shortly before Christmas. It was like end of November. So basically, the bottom line is we cannot tell which of these three things or which of the changes actually caused the effect. So this is a learning for us, one thing at a time. And now we're basically at the end. So we're rounding off our journey with quick filters. We have, since this point, we have developed it further, but we are also constantly monitoring its performance and, of course, discovering and fixing edge cases. Yeah, so that's our journey with quick filters. If you are living in Switzerland, or if you are planning on living in Switzerland, we are hiring. Yeah, and now it's time for questions. Thank you.
Hey, thank you so much. That was really a nice talk. I enjoyed it. If I got you correctly, so the filters, what you're trying to choose is based on your historical clicks, right? So
Yes.
That's basically like just looking how the users clicked on that. Now, given that you are looking for umbrella and you have an inventory selection, did you consider looking into the aspects of the attributes of the items as well? Because it would be very horrible. You click on parasol and no products come up. Because in my mind, as a user, I want to click on a filter. I want to see some products. Just having this one-sided view, or I don't know if you have done that experiment. Did you see some differences, or did you experience that?
I mean, we are doing a validation, right? That all the filters that we show are present or have products. So we are not showing anything that you cannot click or that you click and disappears. So
Okay.
we are checking that, yeah.
Okay, great, thanks.
I mean, one note on that, maybe the list is dynamic, and then some filters don't appear, and then we cannot show them, right? Like maybe last year we had a different catalog, slightly, and then the tracking data says us, okay, you should show this filter, but it doesn't exist anymore, you know, because these products are not longer in the catalog. It might happen some few times.
Hi, thanks for the talk. These quick filters seem to be pretty useful. Have you thought about integrating these quick filters into auto-suggest?
Into auto-suggest, I think we have something similar, maybe, or not, you could say.
Yeah. So what we have is that in auto-suggest, maybe it's something that you people back there said that it didn't really work for you, but we also have suggestions for maybe a product filter, right? So if you search for iPhone, we would suggest you, do you want to search iPhone in the category smartphone? We have something like that, yeah.
Hi. Quick question on the data that you used. So you said you were checking the filter usage basis queries, or like for every query, right? My question is, why did you use queries instead of categories? Because the finding behavior actually kind of remains the same in the category, right? But if you go at a query level, the usage of the filter anyway is low. And then at every query, you might not have enough data. So why did you choose query instead of category?
So because we are the search team, we are concerning with the searches, right? So that was our first approach, but we also have the quick filters on our category pages. If that makes sense. Yeah.
Okay, sure.
And also maybe we don't show quick filters for every query. We have a threshold, so only for queries who have enough traffic to actually gather some data.
I mean, it's a goodie. If you have it, you maybe add some value for you, and if not, we just don't show anything.
Thanks for the talk. My question is, how did you find the best mix of the 3 scores? There are a million ways to combine these 3 stores. How did you find the best mix with offline experimentation or something like that? Maybe.
To tell you the truth, we took the model as is from this different use case, and there I think we did some testing.
We did some testing.
Yeah,
It was tested.
Abel,
It
our
was
data
tested, yes.
scientist is saying yes.
Trust Abel.
Yeah, so basically we did some offline evaluation for another use case, no? And that's why we defined the weights. And then we actually tried to do 2 A/B tests, but at the end we just went for 1. Yeah.
Always good to have Abel as a backup. Okay. Hey guys, thanks for the talk. Did you consider adding personalization to the filters themselves? Like if you know that like it's a female searching for umbrellas, like showing like female suggestion in the category in the filter already?
It's something we are considering, but we haven't done anything like it yet.
Yes, it's also kind of it involves a lot of teams in the company and some information that maybe is not available for us right now. But this would be something cool. It happens that, yeah, we should show damen or a woman instead of men for some. If you search like pants, you know, and the person is a pant, but it needs more time, let's say.
So, as there are no more questions, thank you for your talk. Thank you for the discussion.
Thank you.